We use these incredibly sophisticated AIs every single day, right? But have you ever stopped to wonder how we actually teach them to be, well, good? How do we make them helpful and safe? It's not just about cramming them full of data, it's about teaching them our values. And today, we're diving into the groundbreaking technique that makes this all possible: reinforcement learning from human feedback, or as we'll call it, RLHF.
And this quote, this really gets to the heart of it. This is basically the North Star for anyone building these AIs. You see, the goal isn't just to create a machine that can spit out facts. It's about building one that aligns with our ethics and safety. An AI that's helpful, but also harmless and fundamentally honest. You need all three.
So that brings us to the million-dollar question, doesn't it? How on earth do you teach a machine what good even means? I mean, think about it. Good is subjective, it's nuanced, it's packed with cultural context. You can't just write a line of code that says, if response is good, do this. It's so much more complex, and it's truly one of the biggest challenges in all of artificial intelligence.
This whole challenge actually has a name, the alignment problem, and it's a big one. It's the critical task of making sure that as AI gets more and more powerful, its goals stay lined up with our goals. How do we make sure it's working for us and not in some weird, unpredictable way we never intended? Well, the solution they came up with is surprisingly clever.
To solve this big alignment puzzle, researchers had a brilliant aha moment. They figured, instead of trying to write a giant rigid rulebook for what good is, what if we just let the AI learn it directly from us? This idea led to a really powerful system with a human right in the feedback loop.
And that brings us right back to RLHF, reinforcement learning from human feedback. It's a total mouthful, I know, but the idea behind it is super simple. Instead of just marking answers right or wrong, this method uses our preferences, our simple judgments about what makes one response better than another, to guide the AI's learning.
Honestly, the best way to get this is to think about training a puppy. Seriously, you wouldn't give a puppy a textbook on how to be a good dog, right? Of course not. When it does something you like sitting on command, you give it a treat. You reward it. You reinforce that good behavior. Well, RLHF works in pretty much the same way. It rewards the AI for generating responses that we humans prefer, teaching it through positive reinforcement.
So how does this whole recipe actually work in practice? It's a surprisingly elegant three-step process that takes something really fuzzy, our human intuition, and turns it into a clear mathematical signal that the AI can actually understand and learn from. Let's break it down.
All right, step one, you collect a bunch of examples. You have actual people look at a prompt and two different AI answers, and they simply pick the one they think is better. That's it. Then, step two, all of that preference data, thousands upon thousands of these "this is better than that" judgments, is used to train a whole separate AI. This one is called a reward model. And finally, step three, we get back to our main AI, it starts generating responses, and it gets a score for each one from that reward model. The AI then fine-tunes itself, basically chasing higher and higher scores, which teaches it to give us the kind of answers we've already told it we like.
Now, that reward model from step two, that is the absolute key to this whole thing. You can think of it like the AI's conscience, or maybe an internal compass that's been calibrated to what we humans prefer. It's the magic translator, turning our messy, subjective values into a clean mathematical signal. That right there is the secret sauce that makes RLHF work. But, as powerful as this all is, RLHF is not a silver bullet. Not by a long shot. Like any technology, it has its own flaws and limitations. And it's really important to understand these trade-offs to get the full picture of AI alignment.
So what are the big hurdles? First, there's bias. The model is learning directly from people, right? So if the human reviewers have biases, and let's be honest, we all do, the AI is going to learn those exact same biases. That's a huge deal. Then there's the cost. Gathering all this high-quality human feedback is super expensive and takes a very, very long time. And finally, there's this tricky problem called over-optimization, or sometimes reward hacking. This is where the AI gets a little too clever and learns how to game the system. It finds loopholes to get a high reward score without actually being helpful. It learns to please the test, not the user.
But even with those limitations, you absolutely cannot overstate the impact of RLHF. It was a true game changer. It fundamentally changed how we build and refine these large language models, and it paved the way for the kind of sophisticated and helpful AI assistants we all use today.
What RLHF really did was prove this revolutionary principle. You can use human preference to guide an AI. It did this with that complex multi-stage process with the separate reward model. But of course, tech never stands still.
We're already seeing newer methods like DPO or direct preference optimization. These are often simpler and more efficient. They take the same preference data but use it to tune the AI directly, skipping that reward model middleman entirely. So they aren't replacements, they're evolutions, standing on the shoulders of the giant that is RLHF.
So the next time you chat with an AI and it gives you a helpful, nuanced, and safe answer, you're seeing the direct legacy of RLHF. This was the breakthrough that proved we could teach a machine not just what we know, but more importantly, what we value.
And this leaves us with one final pretty deep thought to chew on. RLHF, in a way, holds up a mirror to all of us. The AI learns from our preferences, reflecting our collective judgments. So the ultimate question isn't just about the technology's flaws, it's about our own. If an AI is trained on our preferences, what does it say about us when that AI gets it wrong? That's a heavy question, and it's one we'll all need to grapple with as these systems become an even bigger part of our lives.